So first thing is we need to identify what is my output data, how my output data looks like, and accordingly I have to take a call. If it is okay, let me take some other data. Let me show you something. So this is a data set of housing. Okay, let me just bring this here so it will be easy for you guys to understand. Right. So here, so this is a housing data set. So this has data for, a particular flat or a house or something like that, which talks about your area, the square feet, how many bedrooms, bathrooms, how many stories the building is. It's a 3-story building, 4-story building, whatever. Main road, is it near? Yes or no? Guest room it has, yes or no? Basement, hot water, this is furnishing status. Is it a fully furnished, not furnished, semi-furnished, and all of that. And this is a price at the end of the day. So if we look at this data, we have to, take a call on what is the need. Let's say there could be two type of scenarios, in an actual industry. Either somebody will tell you what to do, that will be easy. Else somebody will come, give you this data set, and they will ask you, what do you think we should do? So for the later case, if somebody comes to you and asks you like what exactly we should do, you have to look at the data and identify if there are numerical features. Now, don't get confused with these numerical features. These are also numerical features, right? 1, 2, 3, 4. This is 1, 2, 3. So this is also numerical.
Numerical,
And these
yes,
are
yes.
categorical. These are strings. These are
Okay.
strings. These are categoricals. Now, even though these things are numerical, this bedroom, but the final outcome is limited. It's not something which goes from minus infinity to plus infinity. Like area can be anything, but your bedroom will have a limitation. It will be at max 10, 12, 50. It cannot be like it go on and on. It cannot be like 100, 200, 300. It cannot be like that. It will be in a certain range. So for those kind of things, we will tell them that those are categorical features, even though they looks integer or floating point to us, but these are categorical features to us. So if again coming back to the main problem, if we look at this data, we can say that this is a housing data set where the final prediction would be on the price of a particular house. We have been given all of these data. We have to take all of that data under consideration so that we can predict what will be the final price of that particular house or that particular flat. So if this is a particular flat, if these are the conditions, then the price will be this much. Same goes for the other. If this is the one, then the price will be this much. So on and so forth. So this is something that will be given to me. So once I open, I clearly understood that this is certainly my final data set. We call in statistics they as dependent. We call them as dependent variable. Why? Because this variable is dependent on these variables. So from column A to L, these are independent variable because these values can change on its own. But if these values are changing on its own, they will have some effect on this column M, which is price. Hence, column M is an dependent variable which depends on these variables, and these all rest of the things are independent variable. Now, coming back to the main thing here, we have seen there are two types of things. One is classification, one is regression. For classification, we are just classifying based on some existing classes. We are not creating a new class. That is the first thing for classification.
And no, no, no.
So for classification, we are not creating a new class. We are using the existing classes and fitting the new data into one of those existing classes. That is what classification is all about. However, on the other hand, regression is something that we are predicting completely new. That value might or might not, be present in my existing area. So again, if we come back here, this is a price. So let's say how many data it has. This has 545 rows, right? So let's say I build a model regression model based on these data, based on these 545 rows. Now my model will be able to understand, okay, this column from A to 6 are somehow playing a role to calculate the column M. So it will create a relation, it will create a mathematical equation. So it will create a mathematical equation to connect all of these in one single thread to be able to calculate this one. So once that equation is ready, once that formula is ready, all it needs to do is next time, let's say somebody comes with a new set of values. So it needs to plug those new set of values into the equation, which will give you a new price, which might or might not be present in the existing ones. Hence, all of this are regression analysis. So this is regression. So is this thing little bit clear now, or it is still confusing?
Still need some more, I think.
No worries. Let's try this one. So this is another data set. So the data set is heart disease or something, right? So it has age, it has the sex, the gender of a person, it has BP, which is blood pressure, it has cholesterol, and it has another column which is heart disease. Now, what we can do here, so we can say we have to see what is the value of the heart disease, 201. So we can conclude this is a classification problem. Why? Because all these are combining, are correlating in such a way that it will tell me whether that person has heart disease or no. So 1 means yes heart disease, 0 means no heart disease. So to calculate that, we need these variables. Now there is something called, so we will talk in details later, but for now just understand one thing. There is something called correlation, and there is something called causal. Correlation means how two columns or two variables are linked to each other. If I change one, how the other one will be impacted. Example of correlation would be your cloudy and rain. So these two variables are correlated. Why? Because more the cloud, more the chance of rain. Less cloud, less chance of rain, right? Another could be let's say strike rate of a cricketer. So more the strike rate, more chance that more runs are going to be scored by that particular person. So somebody who has, let's say, strike rate of 150 might score runs more than somebody who has strike rate around 50. So these things are known as correlation. So correlation, like how one variable is affecting the other variable, how one variable is affecting other variable. So if we look here, we can clearly tell that if age, gender, blood pressure, and cholesterol, if we can combine these, we can tell that this will have a direct implication of a heart disease. We can tell that somebody with high cholesterol, somebody with high BP, if that person is male and if the age is really high, that will have a tendency towards heart disease. So we can predict that. We don't need to be doctor for that, right? That thing is known as causal and correlation, both, because there is a direct cause, logical cause involved to it. This thing is not completely statistical, this thing is not completely on paper, this is practical. On real life, this thing could happen. Like somebody who has age around 20, gender, BP less, and cholesterol less, will have a less tendency of getting a heart disease compared to a person whose age is really high, high BP and high cholesterol. So that thing is a combination of correlation and causal, like the ones that we were showing here. So if one is correlation, the other one will be impacted if the correlation is really high. And that is the cause of causal. Now, if there are data sets, there are multiple data sets, we can see, let's say there is a variable which is number of animals in jungle, and there could be number of cars by Tesla. Let's say these are two variables. Now, statistically, if the data are stored in such a way that, let's say, if statistically, if we do some correlation calculation, we might get a high correlation between these two. That is possible because Statistics does not know if really these two are linked or not. Statistics will consider numbers and tests, and if those numbers and tests are aligned in a particular direction, statistics will tell you these two are correlated. But practically, if we look into the situation, we will say that yes, these two are correlated, but there is no causal in this case, because practically number of animals in a jungle has nothing to do with number of cars manufactured by Tesla. In whatsoever, in any scenario, these two are not linked. So we will tell this is no causal. So there is no cause involved between these two. Correlation, fine. This could be correlated, but there is no cause involved. Now, why I am talking about this is to identify which variable we should choose. We have to consider both of them. Like in our housing data set, if we go back now, if we see all of these factors, we can say these all are linked. So there is a cause involved, and that cause is making the price higher. Like if the flat is near to main road and compared to a building which is not near to the main road, obviously the price will matter. We don't need statistics to tell me that, right? We can tell this on our own, and same goes for rest of the variables. Like air condition, a flat having air condition compared to a flat does not having air condition will have a difference. Now, this is not one variable. If we take all of these variables together, we will see there is a causation and there is a correlation thing which is playing a role to play around with the final variable, which is the independent variable. Same goes for here. There is a causation, there is a correlation, which is playing the final one. Now, let's do the other way around. Okay, let's see the heart. Can we tell that somebody whose age is something and BP is something and has a heart disease, can we predict his cholesterol? We might not. We might not. Because even though we will be able to find some correlation, we will not be able to tell that the causal, like there could be scenarios that somebody does not have a heart disease, will have very low cholesterol or will have very high cholesterol. So that way is certainly not going to work. But the other way has to work. So these four should play a role to calculate the heart disease of a person. Hence, column E will be my dependent variable because this is dependent on all this, and these four are independent variables because they can change on their own. But the heart disease is something which depends on this. So are we clear on that part until now?
Yes.
So we are getting there, right? Like the basic, at least we are understanding.
Yeah.
So this one, heart disease is something which is getting influenced by this, and same goes for the pricing data set. The price is getting influenced by these variables. Now, the important thing that we have to do is we have to calculate what. So we understood that this is a machine learning problem. Now, where exactly will it fall? Will it supervised, unsupervised, or reinforcement? You can ignore probably because that's is something that is getting consumed in lately in, if you have heard of chat gpt and OpenAI, LLM, so it's getting consumed on those areas, so we can ignore the learning, this one reinforcement for now. Let's focus on these two, supervised and unsupervised. Supervised is something where we are predicting something at the end, either a categorical variable or a numerical variable, and we do have a label associated to it. We do have a label associated. What is label? Label would be the name of that particular class. For this particular data set, the name of the class is heart disease. So we know what we are predicting. We are predicting heart disease. Same goes for housing data set. We know what we are predicting. We're predicting price. So that is the label. And the second condition is, or let me just write it down here as well, should have a label, and this should have a label and supervising, basically, how would I put it? There should be label and predicting a final value. Let's keep it simple. Let's make it easy to understand. So supervised machine learning are those machine learning algorithms where we do have a label in the final data set, the data set that we will receive, and we are predicting a final value at the end of the day. If these two conditions are meeting, then This is a supervised machine learning algorithm. So if again we are coming to heart, do we have a label in place? Yes. Heart disease. Do we have a variable that we have to predict? Yes, this is, and we are predicting whether the final result is going to be 0 or 1. That is what is that sound? CN is joining twice. Heart disease is something that we are predicting. Once we will get a new set of records with age, sex, BP, cholesterol, we should be able to tell whether this one will go into 1 or 0, right? So the final would be like this. The final would be, you will have these values and you have to tell what is the final class. Is it 1 or 0? If we are dealing with those kind of situations, then this is a classification problem, because what are we doing? We are classifying. Classifying is what? Classifying is separating between multiple things, whether it's class A or B or 1 or 0 or something else. We are classifying between different variables. So that is a classification problem. On the other hand, for housing, we are not classifying, we are predicting, we are forecasting. Just understand these terms. We are forecasting a new value which does not exist. Based on the existing values, or let's say these are my existing values. Now let's say somebody gave me a new set of values which looks like this. I should be able to tell, if these are my inputs, what will be the price. If the price is 5 crore, let's say, if we can do that, then this will be a numerical final outcome, which is a regression analysis. So are we clear on this part? The basic difference between, the classification and regression. Hello?
Yeah.
Any doubts? Just feel free to ask.
No.
Okay. So let me give you a thing to both of you. Let's say there is a data set for CN. Let's say there is a medical data set. And 1 second. Let's say there is a medical data set which has, let's say, doctor name, doctor fee, what is the fee that doctor is taking, and number of patients, and let's say doctor, let's say degree, whether the doctor is MD or MBBS or something else, and location type, let's say location type as in, like, is it a clinic or let's say a big hospital like Apollo, or is it like a simple mohalla clinic, or that person is directly coming to your house, right? Like an in-house doctor or something like that. If we have these kind of data sets, can you tell me? And let's say if I ask you, where exactly, what type of machine learning thing that we can do on this? Can you just put some thoughts? Let's say we have 50 rows of information. This many, let's say this many number of information, this many rows of data we have. Let's assume some number is there. Now doctor name is certainly will be a string, doctor something. Fee is something which will be certainly a number, like 500 rupees or something. Number of patients that person is like, seeing in a day, probably like 10. Doctor's degree will be a string, let's say MBBS, and the location will be either of the thing, like, and we have this data set for, let's say, 500 rows or something like that. So what do you think we can do? Your number of patients. Exactly. That is what yeah, you're right. And what type of, so this is clearly supervised machine learning. And so what type of, algorithm it will be? Will it be a classification or regression?
It will be regression.
Exactly, yes, correct. So this will be a regression. So based on whatever data we have, we can either predict this one based on the other. So at one point, there could be two scenarios here. One scenario, we are making fee as the independent variable. So IV independent variable will be fee, and rest will be my dependent variable. So doctor name, anyway, so see, these names and all are anyway not going to matter, because whenever there is a string with names or this thing, anyway we have to drop them. That will add no value. But for now, just keep that in mind, that we have one variable, we have number of patients, the degree of that person, and the location where the doctor sits. We can combine these variables and we can forecast or predict the fee of the doctor. So if these many things are correlated, we have to see what is the correlation, and certainly they will have a cause. So if the person, if that particular doctor is certainly coming to your in-house, then obviously the fee will be less compared to if the doctor is sitting in Apollo or some high hospital, then certainly the fee will be high. So, and also another major point would be the degree of that person. If the person is MBBS, then the fee will be less. So there is clearly correlation and causation involved, and same goes for the patients. So more than anyway, so I mean, this thing could be optional. This thing, I mean, we cannot say for sure if number of patients are more, doctor will take less money or more money. But to some extent, this will also have a correlation and a causation. Same as the degree that we have seen, degree has a direct causation and correlation. Location also has a direct causation and correlation. So scenario one, we can predict, we can create an ML algorithm, a regression analysis, which will predict the fee of a doctor based on this existing data. One thing. Second thing is, this time, let's consider this number of patients as the final, independent variable, which is number of patients. Now, doctor name is anyway, it's not gonna make any sense. Fee is certainly going to play a huge role here, because let's say the fee of the person is 2000 and the fee of another person doctor is 200. So this will play a major role in predicting number of patients that the doctor is going to visit, right? Same goes with the degree, which we have already seen. So a doctor will have a higher degree like MD or something. Of course, number of patients will go there compared to a doctor who has just freshly graduated from college and has just started practicing. That person, that doctor will have less patients, because patient will trust more to the doctor who has higher degrees or a postgraduate degree or some specialization, surgery or something like that. And same goes to the location. Now, in this case, like last time we saw, these two might or might not be correlated. This time, the number of patients will have a correlation with the location, because certainly these two might or might not have any correlation this time. It depends. If it is a clinic or Apollo or in-house, the patient, flow will go up or down. That depends completely. That has very little role to play compared to the other two factors. So, long story short, we can consume. So if somebody gives us this data and asks us to do something out of it, what are we going to say? We will reply saying, based on the data that we have seen and understood and analyzed, we can say that this is something which will be a regression supervised machine learning algorithm, a regression analysis. And also there could be two scenarios that we can do. Scenario one, we can predict what will be the fee of a doctor based on the existing data. And scenario two, we can predict how many patients a doctor is going to get based on the existing data. So these two are examples of regression analysis, right? You guys understood, right?
Yeah.
Hmm?
Yes.
So that is on the supervised machine learning algorithm, where we are either classifying things into individual already populated buckets, or what we can do is we can predict or forecast the number of the numerical things. Now, can you think it from a classification side? Can we do something? What if I tell you that this could be my independent variable location, and we can predict based on existing data what could be my location, what could be the location of a doctor based on existing? Can you agree? Do you think that is possible? Like, let's say there is a doctor, we know the fee of the doctor, we know number of patients he attends, and we know the degree that he has, we can predict, no, but this prediction, this classification will not be very accurate. But
Yes.
to some extent, we can predict based on the fee of the doctor, based on number of patients he attends, and the degree that he possesses. We can probably make an estimate on what could be the location of that person or that doctor, whether that doctor sits in a small clinic or a big hospital, or that is more of like a house surgeon. We can predict that. So if we consider this as my independent, then this whole thing becomes a classification problem, right? So what we are trying to see is within same data, within same within same atmosphere, can we apply both, or can what could be the possible solution out of it? Now, again, it depends on what the business problem is. Now, your client might come to you with a problem like, hey, this is the data. Just tell me what could be the fee of the next doctor based on this data. So you know this is a regression problem. Or if they comes with, hey, I need to know whether this person sits in a clinic, Apollo, or in-house. You know it's going to be a classification problem. But you should go through each and every column, understand what a particular column, the role of a column is, and how much this one can influence other columns. So once you get a clear idea on this, this will be easy for you to take a call that whether what kind of a supervised machine learning it is. Now, going back to the main thing, supervised machine learning. So this is all under supervised that we were talking about. There is something called unsupervised. So what is the basic difference between these two? The basic difference is supervised needs a supervision. Supervised needs this supervision that I have to take this column, I have to declare this is an independent variable, this is a dependent variable, and this is something that we have to predict. So we have to tell all of these informations to the computer. But that is not the case with unsupervised machine learning. With unsupervised machine learning, as the name says, like this is like, uh, clustering and segmentation. So this data has no label. We and no new predictions are happening. No new predictions are happening, and we are grouping rows together. If that is the need of the hour, if this is the need of the hour, then this will be an unsupervised machine learning. Now, what is that unsupervised machine learning? Let me open some data here. Let's see what this has. It could be complicated. Right. So this could be a good example of unsupervised machine learning. Now, supervised we have seen, it has to be classified, it has to regress. Now, if the requirement is to not do any of this, not to classify, not to regress, but rather this is a cricket data set that we have given where this is player, how much time they have played, matches, innings, runs, high score, and all of that, number of hundreds, 550s, zeros, strike rate, everything. So if we were given this data set and if we have been asked to, group them, based on these features, we have to group them. That will be my classification. That would be my unsupervised machine learning technique, where we are not predicting a new column. Are we predicting something new out of it? No. then of course this is not neither classification nor regression. All the existing data we are consuming, whatever data we have given, and we are clubbing, we are creating groups out of it. So let's say we have taken all these runs and hundreds and strike rate and all of that, and we can say this is one group. I'm just making it random, so don't think, right, this number is this number different or that number different. So what we are doing is we are grouping them. We are grouping them. This is one group, this is one group, and let's say this is one group. Right. So these are the three groups. So this is probably group one, and the next one would be my group two, and the next one will be group three. So what I did basically, I created three groups out of it. Now, how this will help me is how unsupervised will help us is unsupervised will help us to deal a certain number of rows in a certain way. Now, cricket is not really a good example, but in banks or in, let's say, Amazon. So Amazon gives us offers, right? So do you think Amazon gives everybody same offer, or
No.
Flipkart for some matter? No, right?
Uh,
Amazon, one fine day you might receive a mail like Amazon is giving you 5% discount, but it might give me a discount of only 2%. Why? Because of the backend data Amazon has of us. Amazon sees Ranjit spends, every 2 days. Ranjit's minimum purchase is 500 single time. Ranjit, is a frequent buyer. Ranjit pays on time, or he always does, net banking. On the other hand, let's say there is another person, that person makes purchase once in 6 months, that person makes purchase of only 20-30, that person has a lot of return, like that person has returned a lot of product, has taken then returned, then again taken and then again returned. So Amazon, what will do, Amazon will group us, or the term would be cluster or segment. The right word will be your, you can either call it cluster or segment. Amazon will segment us into broadly three categories. And so that was for your understanding. Now come back to the Indian, this cricket data set. So let's say ICC has to group them. So ICC will consider all of this data, and ICC will say these are the best batsmen who have scored heavy runs. These are the mediocre ones who have scored decent runs and were decent match winners, and how, and they might say these are the lowest ones, mostly bowlers and all those things. So ICC will create three segments for them: segment one, segment two, segment three. And based on that, ICC will probably give them incentive, or probably give them, their money or some retirement or some fund or something like that. Same like Amazon. So based on our details, Amazon will give different offers to different people. Similarly, here in cricket, all these players will be treated differently based on their performance. So for these kind of situations, we are not predicting something new. Whatever data we have, we are using that only, right? So that is an important point, and let me write that as well. Group together and no new data. So for unsupervised, we don't have new data. So client will give us existing data only. Let's say client has given us this data sets of, how many rows it has? 79 records. So out of those 79 records, client will ask us to just group them into individual segments. Segmentation 1, segmentation 2, segmentation 3. We don't need an independent variable for that. We are not predicting something new out of it. We are not classifying them. Rather, existing things, we are just putting them into different buckets. That is what unsupervised machine learning is all about. And this whole technique, what we have been doing, this technique is known as clustering, because we are clustering them into individual buckets. Are we clear on that? Any doubts?
It's clear.
Huh?
Clear.
CM?
Yeah, it's fine.
Do you have any doubts?
No,
Feel free to ask.
yeah,
I cannot hear you.
no, it's fine till now. No, I don't have any doubts.
You don't have any queries.
Not yet.
Good. So let's say I've randomly created a data set. There is age and there is weight. This is all random. So don't think logically why the weight is this and height is this and like that. So this is all random. So if I create a scatter plot, this is how the scatter plot will look like. So what this scatter plot graph will tell me? The scatter plot will tell me that these points are clearly following a particular cluster. So this could be cluster 1 and this could be my cluster 2. That is what unstructured machine learning is all about, unsupervised. So let's say if this is the master data and client has asked us, can you cluster you these into multiple buckets based on their age and weight? So you will just take this data, you will do your processing, Python coding and all, and you will say, yes, we can divide them into 2 clusters. This will be my cluster 1, the points which are on little until 20 to less than 40. When the age is less than 40, that those will be probably cluster 1, and these points probably would be my cluster 2, right? So that is what unsupervised machine learning is all about. We are not predicting new, we are not doing anything classifying, but we are just grouping the existing data. So there is no new data into it. That is one thing. Are we clear on that part? Because I will jump into supervised from here based on this data. No doubts, right?
Yeah.
Okay. So clusters, just think it like clusters are, what is cluster? A cluster literally means things which are together, one set of values. So these all are clusters. That means there is something common or similar about these data points. That's why this is one of the clusters. Similarly, this big thing, these 6 data points are also somewhat, closed or related to one another. So this could be cluster 2. But if we have to go granular details into it, then we can say, this 1, 2, 3, 4, 5, 6, 7, 8. So this could be one cluster. The line in between these 5 data points, this could be second cluster. These 3 could be third cluster, and these 3 could be fourth cluster. So there are 4 different clusters here. That means these data points are more linked and close to each other. They do have a similar pattern into it. They do have a similar kind of, they behave in a similar way. That pattern matches, right? So if we have to deal with these kind of problems, that is clearly unsupervised. That is clearly unsupervised. Now, that is one thing. Now, just let's jump into supervised from it. Let's say we have been asked that this is your age, you have to predict weight. And this is your data set. This is your data set. So take this data and come up with a model which will tell you, which will help me to tell that if I enter a certain age, I should be able to tell the weight of that person. So in Excel, of course we can do it in Python, but we'll see that. But in Excel, how can we do it? Now the problem here is this data is certainly not good. This data is certainly not good. If I try to change it, yeah, now it's better. So let's say this is the data that we have been given, age and weight, and this is how the data looks like. These are age and these are weight. So this is one thing. So quickly, if I have to do something, what can I do? I will go here, I will add a trend line. The option will be linear. Linear means line. And I will just enable this option, display equation on chart and display R square value. So this will come here. Now, R square is something which talks about the accuracy of a particular relation. But before going into it, just understand what this is telling us. So this line, what this line is doing. So these are individual data points, right? On a graph, these all are individual data points. This line is trying to go through in such a way that it connects all the points. Now, if I put a straight line, of course, it is not possible to have all the points in one line. But at least you pass it through in such a way that all the points are not very far from you. So it's more or less like these all are individual houses, and you have to create a road through that, through those houses. Now, it's not possible to have a straight road which connects all the houses. You cannot do that. But you have to keep in mind that the houses should not be very far from from that particular road. So that is one thing that you have to keep in mind. So this is that particular road, and this is that particular equation that will come at the end of the day. So this equation talks about how much these houses, I mean, how can we predict some new house that will come down the line? Let's say if so this line will remain straight, right? Okay, let me just write the formula here. So y is equal to, y is my independent, x is my dependent variable. So is equal to 1.2068 into age plus 28.957. So let's say if I put 60, this is what it will give me. So if yeah, my prediction is right. So this is something that I'm predicting. So my prediction is right. So I can do something else. If I predict the age is 80, can I get something? Hold on. Yeah. So whenever I'm pressing 80, what I'm seeing is I'm getting weight as 125. So see, the good thing is these all points are falling in a line. So the line, that imaginary line that we had created earlier, they are going in a good direction. They all are falling in that particular zone. So the point I'm trying to make is the difference between an supervised and unsupervised is, for an unsupervised machine learning problem, we will not generate something new out of it. We will take the existing and we will just put them into individual segments, individual clusters. We will find the pattern, the hidden pattern in them, and we will just put them into individual clusters. But for the case of a supervised machine learning, initially we will be given with some data. Let's say this is what we were provided initially. And based on that, we will try to create an equation, the mathematical equation that I wrote here, and we will leverage that mathematical equation to predict future values. So that is how, so these will be new data. This will be completely, some new data, this yellow one, but the other gray, this, the light brown one. So these are your existing data that will be given to you. So you are predicting something new based on the old one. So that is the clear difference between supervised and unsupervised. So are we clear on that, right? So that is the basic difference between supervised and unsupervised. Now, supervised and unsupervised has a lot of algorithms inside of it, lot of algorithms, and they are pretty huge. If I have to put it like this quickly, I can name a few. First one would be logistic regression. Then there is a linear regression. There would be SVM. There could be decision trees. There could be random forest, and so on and so forth, etc. Similarly, for unsupervised, we have again a lot of things. What they are? Mainly clustering. K means clustering, and PCA, LDA. So these are the different things that we have as part of the unsupervised machine learning things. So clustering, as the name says, it clusters. PCA, something like that. Here it's logistic regression, linear regression. Linear regression is a regression, numerical regression forecasting technique. Logistic regression is a classification, algorithm. So these all are individual machine learning algorithms. Decision tree, random forest, and so on and so forth. So that is what, in short, about supervised and unsupervised, how to identify between supervised and unsupervised, when to apply a supervised and unsupervised. So once that part is done, so this is all about your machine learning. So you are telling your machine to learn this and this. But so that is all about machine learning, right? After machine learning, there comes the most important and gigantic thing, which is deep learning. Deep learning. So what is deep learning? So deep learning is again a small subset of machine learning. Deep learning is what? A small subset of a machine learning. So just think it from this perspective. So AI is, what is AI? Artificial intelligence is your flat, right? It's your home, it's a flat. Within AI, so AI, let me put so it will be easy. AI is your flat, right? Within AI, there is a small thing which is known as machine learning. So let's say that is probably a small room in your flat, right? That is probably a small room in your flat. And within machine learning, there is something called deep learning, DL. So that is probably a cupboard within your room. So that is traditionally how it goes. AI, machine learning, and deep learning. AI is the big one. Within that machine learning, we have seen machine learning are things where we write Python codes and basically we take data in CSV Excel format. We tell computer what to do and it does. Deep learning is something which is again one level down, one level, it goes deeper. Now, in short, I'll just tell you what is a deep learning is. Deep learning are, okay, so just imagine, so this is a clustering problem that we were doing. Or let's say this is, where is that heart one? Yeah. This is a heart disease prediction problem that we were trying to solve. How many rows we had? We had 270 rows. So number of rows 270, right? Now, just imagine, let's say there is a new data where these are the number of rows. This will be too long. Let's say 27 million, or let's say 2.7 million, or 2.7 billion, or even more. It could be anything. So do you think in that case the same way we can tackle this problem? The answer is no. We cannot process that much data easily and in such a speed. We cannot do that. So we have to use a technique which is known as neural network. Is a technique which is known as neural network. Now, neural network is something that is like so that has a lot of processing happening at real time, and it leverages the speed of GPU, which is graphical. Have you heard of the name GPU? GPUs we have heard because once we were playing games, that time probably we have heard of GPU. Like a lot of new age games are so high resolution, they will not support on our normal laptop. So we need a GPU, RAM, or a high-end memory, NVIDIA graphics card or something. So that graphics card is basically your extra set of memory to run those many pixels on the screen, so that the video game will not appear to be as fuzzy or hazy or something. It will appear clear, crystal clear. So in similar way, to tackle so much of data, we need a technique which is known as neural network, which will tackle those many number of records, processes them, calculates the machine learning models, and eventually gives us an output. So that's about how a neural network works. That's about what a neural network is. So we will not go deep into it because that will be too much of a thing. But just understand that's when we need a neural network to process this much amount of data for us. When the number of data is high, okay, understand we were just dealing with text here. Sorry, these are just numbers. What if we upload an X-ray image and there is a ML model which will tell me that this X-ray patient has pneumonia or not, or this X-ray patient has some other disease or not. So to solve those kind of problems, we need neural network, which comes under deep learning architecture. So deep learning is a type of architecture which leverages neural network to solve high-end, data processing problems. So that is what DL is all about. So any questions until now? So today I'm planning to stop now at 9:45 and we can start again from Monday. So if you have any doubts, just let me know. Anything until now? What is AI, ML, DL, and what is all of that? We've talked a lot on classification and regression. The reason I talked on these things is next we can probably jump into, okay, so this is one Excel file, right? So if we go into Python, we will just bring this whole thing in Python in Pandas framework, and this whole will be my data frame. So we will see how we can play around with these columns, how we can filter these columns, how we can add a new column based on this, how we can change this column. So what if I need to change the name 1 to male, 0 to female? What if I need a flag or BP? Like if the BP is greater than 120, we will call it high BP. If it is less than 120, we will call it as low BP. So those kind of flags we have to create, if else. So all we will be seeing in Python, which will intake this entire data as a data frame, and then it will start processing on it. So I think that's would be sufficient for today. Just digest it. It was too much of a thing for you if you are not aware of it. So any questions, or we can probably wrap up for the day?
We can wrap up.
Sian, you have anything to ask or any questions? Okay, so meanwhile, if you have any questions, just feel free to put your questions on the WhatsApp group. So by the time we'll start on Monday, we can probably solve those questions first and then we can start. Yeah, so whatever questions related to anything, ML,
Sure.
Python, coding, whatever, anything else, just put those questions on the WhatsApp groups and I can probably answer them. Yes.